gonna upload on Blackboard, and
Okay.
I'm gonna ask the questions at the end of the presentation, all right?
Ahí ya se está grabando, pero ¿quién lo puso? ¿Lo
Yo
pusiste
lo
tú,
grabé.
Martín? Okay.
Okay, all right. So whenever you're ready, guys.
Do I share screen or how's it gonna work?
Sí, pues
Yeah.
si quieres la comparto yo.
How
Espera.
disable screen sharing? Ah, okay, yes.
Ahí ven bien.
Yes, there it is. Mhm.
There you go. So I know you already know who we are, teacher, and nonetheless we're gonna present ourselves. I'm Juan Cristóbal Cordero, and
I'm Patricio Vázquez Vela.
so we're gonna present to you our final project. So basically what we have is a pulley system, which is a mechanical traction device that works mostly in order to lift heavy things or to transmit a force. But as I said, most of the times it is used to lift heavy things. It can work according to the second law of Newton: mass times acceleration equals the force. And we'd only have to look to the factors of weight and tension of the device. And our experiment consisted on creating a pulley system to determine how pulleys work and if the weight of an object can be distributed more equally when more pulleys are applied to a system. And our research question is, will the mechanical advantage increase if the system increases the number of pulleys or not? Next.
And then I'm going to talk about the theoretical framework. First, our hypothesis is that if the number of pulleys in the system increases, the mechanical advantage will increase with it, so the force needed to move the object decreases. Our theory is that if we have more pulleys, we will be able to carry more weight and more easily. This is, I mean, we made a really simple experiment, but with it, we could also determine the time of displacement, the effort, the force needed, and the time in which everything is done, as well as the velocity of the cycle, with the purpose of measuring the mechanical advantage and determine the better outcome, hence proving or not our hypothesis. The control would be the number of pulleys and the distance between them in each system, and the constant would be the weight.
So our methodology, we have two variables, dependent and independent. The dependent one would be the mechanical advantage of each system according to the pulleys on the system, the force necessary to lift the load. And the independent variable would be increasing the number of pulleys and changes in the location of the pulley. And we would need 5 types of materials, 4 single pulleys, 1 meter of rope, 5 grams of weight, a spring scale, and a metric ruler. And now, the description of the experiment. As I said before, we lift 500 grams of weight in a single fixed pulley system in order to measure the mechanical advantage. Then we will use a movable pulley and measure the mechanical advantage again, and then we will repeat the same process again and again, each time adding more pulleys to determine the mechanical advantage and its changes. And after it, we'll add up to 3 pulleys.
So now we present you our data collected. It is divided between velocity, distance, and time in the 3 pulleys. So the velocity of the first pulley is 0.55 meters over second. The distance is the same for all 3, but it's 2.20 meters, and the time is 2.401 seconds. The velocity of the second pulley is 0.67 meters over seconds. The distance 2.20 meters, and the time 2.31 seconds. The velocity of the third pulley is 0.79 meters over seconds, and the distance 2.20, making the time 2.28 seconds. Therefore, we could we could prove that our theory, our hypothesis was correct. So when we analyze the results, we could prove and determine that the more pulleys applied to a system of lifting objects, the more mechanical advantage there is, therefore making the process much easier and much faster. Another observation is that the bigger the angle between the object and the person pulling the object, it will be easier and it will require less force.
And now for the conclusion, we concluded that even though there are experiments that are really easy to do, they help you prove or discover points that you didn't previously know about certain topics and make you understand them better, not only in a conceptual way, but also in a practical one. That's it.
Right. And your references. All right, very good. So I'm gonna ask you a couple of questions first, guys, and then we check your presentation. All right. Good. So I'm gonna start with you, Patricio, and I'm gonna ask you, why do you
Yes.
think having more pulleys affects like the time that you're taking to lift something, and also the velocity that you're doing? What physical concept can you think of to explain this?
Well, I think the force is what could explain why this is easier. Because if you are more pulleys, it is easier for you to. It will require less force for you to make it faster and with less energy.
All right. And Cristobal, if you
Yes.
were to perform this experiment one more time, is there something that you would change in terms of methodology or materials that you use?
Maybe I would instead of trying 500 grams, I tried different types of weights in order to determine more changes. But from the main experiment and the concept, I wouldn't.
That's it. Okay. All right.
Oh, sorry.
Uh,
You want me
good.
to explain?
No. It's okay. It's okay. It's okay. All right. So let's take a look at your presentation now. And can you go to the next, please?
And teacher, I can explain something else about the question you asked, Patricio.
Yeah. Go ahead.
That since the energy required to move the thing is the same, since energy isn't created nor destroyed, we use more polysystems in order to distribute the energy more equally, therefore giving a big piece of the total energy into small pieces in order to make it easier and the transition of the movements to require less effort.
Mhm. Okay, all right. And now that you're saying that, I do have another question, and like any of you guys who can answer it,
Mhm.
how did you move this object? Did you like do it with your hands? Was there any kind of device to apply the same force all the time?
No, first I tried moving the arm without, I did it myself, but I took some measurements and I moved my arm the same trajectory, the same space in each without putting any force. I just let my arm move downwards as if I was putting it against my other arm to feel the same tension. I don't know how to explain it. I mean, I used my arm and lowered it with my other arm in order to distribute the weight more equally and to for the weight to be less affected by my arm's movement.
Yes, I mean, obviously we took in account that also that requires force, but it's a smaller force than when he pulls stronger the string.
Okay. I don't know. It's kind of curious because, well, if you do remember statics, guys, when you like distribute the weight in, for example, let's say 4 pulleys, and let's say
Uh-huh.
your weight is 40 newtons, you're going to have 10,
Uh-huh.
10, 10, and 10 in each of them, right? But
Yes.
I mean, like if you're pulling with your arm, you're pretty much doing the same effort, right? So I don't know. I'm not pretty sure that it would work. And now that you're saying that you did it with your arm, well, that's another variable that we have to consider, no? Because maybe you apply a little bit of more force each time, and that's why you're having those values. So I guess
Mhm.
Another way
Okay.
to perform this experiment is to have one weight on one side and the other on the other side. And then just adding the pulleys, right? And just letting it go and let it work the experiment and see if the time decreases or the time decreases, and just check out your results, right? So yes. Now let's go back to your presentation, guys. And from this first slide, I would really recommend you to summarize the text that you're presenting. I think it's too much text for that. I really like that you combined images and yeah, the best thing it will be to reduce that text. If you really want to keep it, well, I would like add animations to like present it one by one and then just doing it that way, all right? Let's go to the next. Theoretical framework, hypothesis. Okay, probably, I guess you do have plenty of space over here, and I like the image, but I would like to see better something related to the project, right? So maybe the drawing of a pulley over there, and then 3 and 4, no? So you start like presenting your project to the people who are watching your presentation, right?
Ya lo reduje, teacher. Ya le quité 2 oraciones que eran extra, que nada más completaban otras.
Let's go to the next, please. Methodology, dependent and independent, the materials. All right, I guess this is okay. I guess over here again, include the images that you did on your experiment. All right, like how you perform it and everything. And
Okay.
let's go to the next, please. Description of the experiment. So again, it is nice the images, but I think it would be better something related to your project, right? Over here, you have plenty of space to include maybe even a video of your experiment, how you perform it, or if you want to a picture over here, and then you just explain everything over there, okay? It's a good amount of text, but you're missing over there the pictures and maybe a video, right? Next. Data collected. Yeah, all right. And well, yes, I guess over here, that was one of the things that we missed now, like the force that you apply each time. Since it was with the arm, well, it was kind of difficult to know how much force you were applying, but I think, yeah, we could have thought of something else to have that force over there, right? Let's go to the next. The results. All right, let's go to the next. That's it. All right, very good. So keep that in mind, guys. Think of another way to get the same force every time, all right? So we can actually prove if you are correct or not. If having more pulleys is gonna help you out to decrease the mechanical effort that you're doing, right?
Yes. Bueno, ya puse las imágenes y ya reduje el texto de la introducción. ¿Te tengo que volver a subir la presentación?
No, you're just gonna upload this video on Blackboard, guys. Your final grade for this presentation is 88, okay?
Okay. And teacher, do we have to crop the video?
No, you don't. You just upload it like this, all right?
And, o sea, sí se puede subir, o sea, tanto tiempo. O sea, no sé cuánto duró, la verdad.
Yeah, I don't know. Probably not. If you want to, you can upload it on YouTube and then just put the link over there.
Subirla a YouTube, ponerlo privado, que solo lo puedes abrir con link y ya,
no, pues
lo...
X, mejor público y ya cuando tenga la calificación lo borro o algo.
Google Drive, whichever you want.
Okay.
All right, perfect. Thank you so much, guys. And
Gracias,
I will
profe.
see you for your exam, all right?
Thank you.
Yes.
See you.
Bye, profe.
Bye, guys.
Oh, I have a question.
Yes.
Do we have any doubts? Can I write you an email or something?
Yeah. All right. Good. Thank you, guys.
Profe,
See you.
rápido. Una pregunta rápido, profe.
Yes.
¿Dónde me sale la grabación? ¿O cómo le hago para...?
You're gonna close this session, and when we finish, it's gonna transform the video into MP4, and then you can do whatever you want with that.
Okay, perfecto. Gracias, profe. Bye.
Bye, guys.
Good teacher. Bye.
Ya.